Hello, good afternoon. Goedemiddag, is it? Did I say that all right? Goedemiddag? There you go, good. That's the only word I've learned over the last 2 days. So thanks for coming. My name is Christos Matskas, or Chris, whatever it's easier. I work at Microsoft as a senior Azure developer, premier field engineer, which is a mouthful, don't even try to pronounce it. And what I do more or less is about Azure and development and everything in between. Over the last few months, we've been working a lot with customers around serverless and Azure. And funnily enough, as an open source advocate, functions fit nicely in there because they're all also open source, which is quite nice. You can find me on Twitter if you want to. If you have any questions after the talk, I'll post my slides there as well. And I also blog about different things, so feel free to hit me. So, once upon a time, 2006, I joined a company that used to process data for the securities finance industry, which is a sub-market of the stock exchange. And what we did more or less day in, day out was processing data. Customers would sign up to send us their data. We would process them into a database. We would aggregate the data and then sell them back to the same customers. That was fun, right? Give us your data and you'll pay us to see them. That's what we did. But the operation was more about processing all these millions rows of data on a daily basis. And we had this tool called the data importer, which was a behemoth of an application that had different stages. The first stage was always reaching out to the customer's FTP site, getting the files downloaded, unzipping the files. Then we would process the files, getting the columns. Sometimes the customers would provide the right format, but customers were lazy, so they would just dump a CSV file to us, and we would have to unravel the whole thing and process the files and then put them into a database. That was it, more or less. And we did that on a schedule base, so we had the task running initially every hour, then we had more customers, we want more real data, so every 45 minutes, then 30 minutes, then 15 minutes, then 5 minutes, but never real time. We could never get real time. And that was because the amount of processing, obviously, and the way that we wrote the application. It was .NET application running on a server, somewhere deployed on a Windows machine. It had to run on a scheduled service with the right account permissions. And we had to use polling. We had to go onto the servers for every single customer, every single time, and say, do you have any data for us? Data. So we use the polling process, or the hammer polling, where we're hammering their servers every 5 minutes. Obviously, the customers didn't mind. But the problem was that we had to do that manually every single time. Now, that was 2006, and it's 2017. So today, if we were faced with the same problem, how would we do it? It wouldn't take us hundreds of thousands of lines of code. I'm kidding you not. We had loads of code to do that. It wouldn't take us servers upon servers. It wouldn't take us a number of decision making like this. Like, how many servers do we need? How often are we going to run? How are we going to scale out? How are we going to manage patching? These are all the decisions that we are faced on a day-by-day basis when we decide to write applications. But it's 2017 and we have functions today. So today, if we were to solve the same problems with functions, it would be totally different. Why? Because we have, first things first, we have abstractions of servers. So we wouldn't need any servers to be there for us to manage. We would be running functions on the serverless platform, which technically has servers, but we don't really care, because what you care about is taking your code and deploying it somewhere to run. This is the beauty of serverless. We will manage the infrastructure for you. All you have to worry about is running your code. So if you're running Node, we can run it on a Linux machine or a Windows machine. You don't even know about that. If you're running .NET Core, which is supported now, you don't even know where you're running. That's the beauty of it, abstraction. And then we go into event-driven. So rather than us hammering that FTP server every single time that we did in my previous job, and it was painful and we couldn't get real time, and we had to run that. We had to burn cycles and CPU and RAM. Now, all you do is just say, I'm going to be listening for an event. We have an event-driven development style where you say, I'm going to respond to something. I'm not going to be running my functions every 5 minutes, although you could do with a scheduler there. But most times these days, you don't really need to do that. You say, if an FTP file gets uploaded on your FTP server and I'm listening into that, then I'm going to process that. Now, we had one application, that data importer thing, that was running for all customers every single time. With functions, you would have a function per customer. So you can have different requirements there, and you have different scalability possibilities for every single customer. So that's very, very nice. And when we talk about instant scale, we can say if you dump one file, we'll run one function. If you dump 100 files, we'll spin up 100 functions. If you dump 100,000 files, we will spin up 100,000 functions. Eventually, it becomes one-to-one almost, where you map and we scale as your demand grows. And then once you dump the next file, we'll just scale down again, so you don't have to pay for extra cycles. And that's where micro-billing comes into play. Is it billing even? Because you have 1 million events processed for free every single month per function up. You can actually run a lot of stuff for free. Or 400,000 gigabyte seconds, which is a calculation between your memory, your CPU, and your time that you're running your application. But since most functions tend to be quite atomic and quite short in time, it tends to not even hit that limit. Mind you, though, we have customers that actually do billions of executions per month. So it doesn't really matter. But for smaller companies or even for banks that we solve problems, we tend to see them not ever hitting that limit. So micro-billing, because you pay per execution, right? And then we have the other stuff. So we have managed applications, and you're managing your applications, not the server. So you actually care about deploying your code. You don't care about how you're going to be patching your servers. You don't care about how you're going to be scaling out, scaling down, which operating system you want to run, and so on. So that's the beauty of it, the abstraction of the servers, and you focus on your apps. You're also getting reduced DevOps. I used to joke about that, saying no DevOps, because we didn't have any DevOps story when we initially deployed Azure Functions. But today we have a really good story about it. So you can use, one of the tools I'll show you is the CLI tools that you can actually push through the CLI to a slot. You can use Visual Studio Team Services to do proper CI/CD. We've moved to class-based deployments for .NET, which means that you can now unit test your code without having those dependencies on the runtime, which was previously a pain with the scripting language that we had. So you can do proper Git flows and everything else all the way to production. And finally, you have faster time to market. How fast? I could actually put that thing together, that data importer thing, in about 2 days. I was thinking about that the other day, how I would do it. So there's tasks for unzipping files without really writing any code using logic apps. So that's the other bit of serverless. There's ways to listen to FTP without writing any code using logic apps. Then you can have things like unwrapping the files and putting them or processing the CSV files using .NET or Node, whatever you like to play with, or even Python. We have all these languages supported, which means that if I had to do the whole process, all these steps and that workflow would be done in less than 2 days. Think about the effort that we put in 2007 in comparison to the effort that we put today. It's insane, right? You can get so quickly into the market. You can create APIs. Like, let's say you have databases, right? You have data. Everyone has database. Everyone has data. Who doesn't have data? No one. And you want to expose that data to your customers. In the past, you would say, are we doing .NET? Are we doing PHP? Are we going to go with Node? Then you have decide on the framework. Then you decide on the abstraction layers and the dependency injection and all these things that go together with that. Today, I can actually have an API endpoint that pulls data from whatever database you might have in the backend, Oracle, SQL, Node.js, and expose that single endpoint API with a key to my customers within 5 minutes. So that can scale. We can see how the customers use that. Then I can add another API endpoint to expose a different part of my data. So in the past, you would have to deploy the whole thing, like write the application, put the architecture there, make sure that it's going to be scalable and performant, and then put that out. So faster time to market. In Azure today, we have quite a few things. We have the core of the serverless, which is functions, which is the compute bit, where you write your own code. Whether you want to have PowerShell, or whether you want to have C# or .NET or Python or Bash or Batch or whatever. And the idea there is you can actually have your own code. Whereas with logic apps, which is the starting point for me, I like to go from there. It's just it's connectors and conditions and output bindings. So you say is if somebody uploads a file on my SharePoint or my FTP server, go and grab the file, crack it open, select the columns that you want to do and push them into another database, and that could all be done without writing a single line of code. So no code, no bugs. If it works, it works. If it doesn't work, it's on us. Blame Microsoft for it. No, don't blame Microsoft, I'm just saying. But if you have a problem with logic apps, you can come to us because it's supposed to work out of the box. It's drag and drop functionality. And finally, the latest kid on the block, which is the event grid service. It's a scalable, unlimited service that can actually manage events, whether you have custom events that your phone creates, that your backend server creates, that your Azure platform creates, your Slack creates. You can actually multicast those events, and then you have multiple subscribers that can process that as you want. And we have full integration now with functions and logic apps. So somebody spins up a server or scales up a server in your VM, that generates an event, you can capture that and then respond by sending an email or whatever you want. So full automation there, and that was the missing bit that we were seeing. And around them, we have the platform. We have the databases, which can be storage, it can be NoSQL, it can be your storage accounts, your storage queues, your security and access control through AD, through MSI now, through service principals, IoT processing, analytics, and finally the intelligence. So people are building bots today by just using services like logic apps and functions. But as developers, we want the right tools, right? So we have ID support, whether you want to use Visual Studio, whether you want to use Visual Studio Code, Sublime, Atom, your Notepad, your Notes, your WordPress, or whatever you want to use, it's just going to work. We have integrated DevOps, so when you create your functions, we give you a GitHub repo inside Azure that you can host your stuff. You don't even need to have a GitHub account, just simple as that. We will host it for you, proper GitHub, or you can use VSTS, or you can use GitHub, and we will connect to them and do deployments if you want to do so. Or you can use VSTS. You have local development. That's a very, very important bit there. And I will stop to that because on AWS, for example, there are companies that are designed to fill that gap. They're built to deploy and run locally. And when I say locally, I'm not talking about emulators here. I'm talking about proper local development. We're talking about an event being raised on Azure or an FTP server that you're monitoring, that propagating down to your local environment where you can set breakpoints and then let it, looking into the data or maybe transforming the data and then push them into your NoSQL database, which can be your Cosmos DB database, all going through your local environment. So you can actually look into what's happening there in the flow. Monitoring, we have beautiful integration with App Insights. I will show you how easy it is to set up. And then finally, visual debug history, which now gets integrated with App Insights. Right, okay, let's go. Next slides. Scenarios, anything that needs to respond to events. The possibilities are limitless. I was working with a customer, it's a major bank, and they said, we want from next year to be able to publish bank statements. Every time a customer closes an account, we need to publish 5 years worth of statements. That's by law now. So every single bank needs to implement that in the UK. And they approached us to say, how would you build that? And we said we can build it very easily by using a serverless platform to do all the back-end processing, and then a simple web app for the customers to log in and select the statements. So they exposed an FTP server where they will upload all the documents, and we told them that we expect a REST request that will have the customer details like name, the account number, and the statements that we can match to, and then we'll do everything else. So we create a couple of functions and logic apps that once the FTP file, the files are there, the customer initiates a nice HTTP request. The request comes in, we spin up our function, we go and grab the data, we put them into storage account, and then the website is looking at that. It took us 2 weeks, 2 people, about 40 hours, end-to-end solution, full CI/CD. Customer is blown up. They come into the site, we do the demo. How much is that going to cost? For 18 million accounts that will be probably processed on a monthly basis as they have accounts closing and opening at the same time, we're looking at about £800. I said, per account? No, we said for the whole thing. What? Sold. Right, it was that easy. We see that all the time when we actually provide that kind of solution to common problems. So real-time stream processing, timer-based processing. I want to look into my backups on my web apps every time at 12 p.m. at night, and then if something has happened, then I want to actually raise an event. PowerShell, 5 lines of code, run on a schedule, done. And then we have mobile app backends where we can create application APIs for your mobile backends or even your web apps by just using functions. So that's really nice. And lately, we see a lot of bot integration where customers want to create bots for the sites and just going to say, well, how are we going to interact with our backend database and how we're going to interact with our customers. We have the bot framework that does all the front-end communication with the customer, and then we have APIs and logic apps and functions processing the data in the backend. Right, enough talking, guys. Let's go and do some demos. Who wants demos? Right. And we'll start with the easy stuff, right? So we have, let me just Control-C that one. So cd up. So this is the, let me just clear this. Can everybody, oh man, you can't see that. Why can you not see that? There you go. Okay. So, oh, that's a bit weird. I have to, let me change my settings here. See, we didn't test for that one. It would be weird for me to just code like this. Right, okay. Is it displays? It should be arrangement, mirror. Hey, there you go. This looks better. So, can everybody see that at the back? You want to make it bigger? So let me just do that. There you go. So we have a core set of tools, the core CLI stuff that can do some really amazing things. So if you type func, and you know it's serious because we have ASCII art. Every time you see ASCII art on a CLI tool, you know that people have paid attention to that. I don't know how long it took them to create it. But the idea is that it allows you to connect to your Azure account. You can list your subscriptions. You can attach the specific subscription, which I've already done. You can create and install extensions. You can create functions. I will show you how. You can run the function locally and debug locally using Visual Studio Code. You can define settings like your storage account, settings like your SQL database backend, settings like your FTP server, for example. And then you can also use some of the templates, and we can extend those templates as well. So in here I have a project. If I do an ls, a list, you'll see I have, no, I'm in the wrong project. So cd func demo. So in here, clear. Changing between Windows and Mac, it just the commands are never the same. So ls here, we have TechDays Netherlands. I have a host and local.settings.json just to explain what's happening. Host tends to be empty, and this is something that we use to tweak the settings on the live environment, so they don't really matter on the local environment. But the local settings.json is where you set up things that are relevant to your local debugging and development experience. If you're doing HTTP stuff, you don't need to set anything in there. For anything else, you need at least a storage account. That can be an emulator, or that can be the real thing if you want to. So in here, just to create a new function, func new, and it takes me through the process. Now, this is a very, very new tool chain that we've released maybe a couple of weeks ago, and we made it cross-platform. So as you can see, I'm actually developing on my Mac, whereas up until 2 weeks ago, it was only available on Windows because we had a dependency on the .NET framework. Now we went all .NET Core, we're cross-platform. But unfortunately, we haven't added all the languages back. So at the moment, you can select only between C# and JavaScript. But just to give you an idea, when we go into the portal, I will show you which languages you can choose. So let's go with JavaScript. So I'll say 2. And again, the templates are only a subset. In this instance, I'll say I want an HTTP trigger. And now we have the trigger. How do you want to name it? TechDays NL V2. There you go. And that's it. It created the solution. We have everything there. And I can actually go back into code, wrong code. Close that. And then go code. How many of you use Visual Studio Code here? I should see every single hand up. Come on. It's an awesome tool, cross-platform. It allows you to do .NET Core, allows you to do Node, and let's make this bigger as well. Otherwise, you won't be able to see this baby. So, installation appears. Your code installation appears to be out of date. It's fine. So you can see we have 2 functions. We have the host and the local JSON, as I was explained. It can stay empty because we're doing HTTP stuff. And then in here, inside my function now, I have my function.json, which describes the bindings. If you've never seen them before, it says what comes in and what comes out. In this instance, we have an in, which is an HTTP request, and an out, which is an HTTP response. And that's all taken care of by the thing. Let me just close that down. So what we're doing here is, just make it a bit smaller and then make it full screen so you guys can see. What we're doing here is we're accepting a request, we're getting the body or the parameters from the URL, and we run it, and if you make a mistake, you get a 400. So if I come out from the full screen, I can now run the whole thing, right? So I can go here and say func host start. Now, if you only have one function, it's quite happy, it doesn't complain. If I have two functions, it will say, I don't know which one you want to start. Or it will probably start both of them, right? So they fixed that one because it was usually you had to define which one you want to run. So I can grab that URL, go here and just call it just for kicks and see what we get. If I complain that it's not post, there you go, you need to pass a query. Of course I need to pass it. So in here we say name, Johan, make it. Hello, Johan. So that runs, right? Now, let's prove the point. Can I actually debug the whole thing? Come into Visual Studio Code, and we have this thing called attached to functions, which already the VS Code recognized. So I'll do that. You can see here it's actually attached. You see that nice plug over there? It says, I'm listening to your requests. I'll put a breakpoint here. And then let's go and run this baby again. Boom, done. So you can actually look into anything, whether it's a blob storage item, whether it's a storage queue item, whether it's an event grid item, full details there. Let's come out of this demo. Let's let it run, and we're done. Now, exciting, right? Local debugging on a Mac, running Azure Function stuff. I can even go into my code here. Let's stop this one. And I can do a push into my production environment. Func publish. You guys see that? So that's already connected to my application, which I already have created. It will go and publish everything. I can also choose whether I want to override my local settings with my local connections, strings and everything with the production environment, or whether I want to keep it. Now, I wouldn't recommend that you do this because this is not CI/CD. We discussed about DevOps, and that's a bit dangerous because I'm now publishing to production. I could be publishing into a slot, which would be fine. But the idea is that this is the same as doing right-click publish on your Visual Studio web app. So don't do that. But if you're in the very early stages, then you can do this because it helps you understand how things will run. Now, if I go back into my my functions, this is our function here called CM TechDays CI, which is continuous integration, which is not really continuous integration, is it? And it will pick up the two functions we have there. In fact, it's exactly the same code, and once I get here, I can actually run it. If you've never run, has anybody seen the portal before? No? Yeah, a few people. So that's the Azure portal. Many people experience Azure Functions only from the portal. They never do any local development, which is fine, but it means that you can't really debug stuff. And for me, I find that a bit annoying when things don't go well. We actually compile your code if it's C#, but if it's JavaScript, there's nothing to compile, so you're done. However, we are adding integration for TypeScript, so now we can actually transpile your TypeScript and throw an error message if you mess up, which you want that to happen before you go into production. And in here we'll say, well, you don't have anything there to let me trigger something. So let's go and say my name in the body rather than the parameters is Christos. I can type my name really fast. I usually mess it up. And if you go down here, you can see the results. So you can actually run everything on the portal without you having to have any tools. And sometimes I always start with that demo just to showcase how easy it is, but now we're doing a little bit more advanced stuff. Okay, going back to our slides. So we've done a few demos, we've done the functions. So I just introduced functions there. I'm just gonna go with the logo because I like the logo. Wow, there. Look at that. Code and configuration gives you love, right? And we have lots of different bindings, so you can bind to lots of different things like schedule, where you run every 5 minutes or every hour, HTTP request or webhooks, so you can hook into events that happen all over the place, blob storage events, queues and topics for your service bus, storage, mobile apps, DocumentDB, and we're adding a lot. In fact, we've just added an extensibility model where you can go and create your own custom triggers. So if you want to trigger something because somebody uploaded something on Slack or because somebody uploaded something on your SharePoint, you can expose that and we can process that as a custom template. So you can tailor it down to your own environment. And something that not many people know about is that functions can run on your own premises environment. So there's this thing called the Azure Runtime process, which you can download and deploy to your servers. So if you have a vast array of servers sitting around idle doing nothing, you can run your own functions inside your own premise environment, and you have your own custom extensions there, which makes it totally yours. You don't even have to run on Azure anymore. That's all also open source. So you can go and download the thing and run it today without having to pay a single penny. So you can spend your cycles and do whatever you want with your local environment. So some of the challenges that we already discussed about is debugging, running locally, connecting to services, monitoring, and as I said, some companies on Azure just work around that ecosystem to provide all these. You can do all these from your own environment, whether it's Mac or Windows or anything else. Okay, these were not an afterthought. We started with that. We knew what the challenges were for our customers. So we have new Visual Studio 2017 tooling. Now, I did say that we just moved into core. So if you are doing .NET Core stuff, you know that it only works inside 2017. I know it's not the best. You know, some customers are still stuck in 2013 or 2015. But because we support the new CS Proj format, we had to move into Visual Studio 2017. But the benefits that you get of that is now you have classes. Unlike the CSX, the scripting languages for .NET, you get full support for classes, which makes them testable and get IntelliSense and all the beautiness of Visual Studio. And we also moved back into the WebJobs attributes that we define for creating your templates and your triggers and so on, which makes it a little bit more fun to work with. If you want more details, I'll share the slides and you can see them. So this is an example about how it looks inside Visual Studio. You have your triggers, you have your outputs, you can have multiple outputs, it doesn't have to be one, right? And then you can get IntelliSense and everything else. Now I would show that, but I am on a Mac. We don't have 2017 support on a Mac yet. So we've done the demo with the CLI. You can get lots of samples from these sites over there. We have lots of things on GitHub. And now I want to move into durable functions. How many of you have heard about durable functions? One person, brilliant. So that's going to make it a brand new subject. So up until this point, every single function was an atomic operation. If you wanted to share state, like I grab some data and then I need to pass the data to the next function, you actually had to go and put them into a queue or put them into storage, and then that would trigger the next function and the next function. So you use that kind of orchestration. And because that was a bit of a challenge, and some customers said, well, we want to run the same function repeatedly, but we want to pass state from one place to another, we came up with durable functions. And durable functions allow you to share state in your serverless solution. It's currently in public preview, which is brilliant because it was in alpha up until very recently. And some of the changes that we announced with the preview are elastic scaling support for the consumption plan. I will get into that in a bit. Cross-platform support for .NET Core 2, obviously. Better traces and integration with app insights. Retry support for activities, because when you run multiple times and something fails, you want that to be retried. Improved error handling with timers. Portal support and templates, so now you can create them on the portal. And we only have support for the 2.0 stuff now, which is the new improved cross-platform things. And that's also for the Functions Runtime, which is the one that you can download on your local machine as well. And the roadmap for that, no, too fast. The roadmap for that, we're going to be supporting other languages. So right now, we only support .NET, because that's our starting point. But you should see support for Node, TypeScript, Python, and everything else that we provide there. Improve monitoring and management for orchestrations. Improve the underlying messaging data. Now, what we do behind the scenes is we're going to create queues for you. So when you want to pass data around, rather than having to manually manage those queues, we manage them for you. So it's all abstracted. Again, another layer of abstraction to allow you to go and do your stuff. And want to have maximum throughput, obviously, and dynamic repartition of orchestrations. Okay, who wants a demo? Demo, right. This is a bit of a tricky thing to set up. So rather than me going through the process and taking 10 minutes to show you, I'm going to walk you through the process of what needs to be done. So let me just jump into the portal again. And in here, I've got another function called durable functions. And we need three things. Now, you can't execute durable functions by default. You can't say, I want to send an HTTP request to that. There's no trigger for durable functions. So we need to wrap them around something nice. And our starting point for that is the HTTP start. And inside HTTP start, once it decides to load, we expose an HTTP endpoint that we can call with a function name. So that would be our durable function name that we want to call over and over and over again. And this one, all it does, it just walks you, let me just hide that so we can see a little bit more. Can everybody see that? It's not too small, that's good. So what we do is we have a durable orchestration client, which is the starter, and we use that one to start the function. Yeah, it's fine. See, we still have a few issues. Now, we also support Swagger integration as well, and because this function is like between HTTP endpoints and durable functions, that's like, I don't know what I'm going to do with my API, Swagger, Open API stuff. So let's ignore that error for now. We are aware of that. And the idea is that we expect the function name to be passed as part of the body, and then we use that one to instantiate our orchestration, which is going to be our durable function manager. So in here, what we do is we have a function in .NET that all it does, it creates it has a context which manages our context back and forth. And then in here in the context, we are calling another function. That's the repeated function that we want to run every so often. So it could be 100 times. Imagine that your context was actually something like grabbing 100,000 files from my AWS account and move them into storage. How would you do that without functions? You would probably write some code, run it on a server, create the connecting points there and do that. What we can do here is we say, do a listing. So the example here would be rather than having an empty list, you would instantiate that list with all the names, and you have the endpoint parameters to go and get those items, and then you would call the same function in a loop. So as long as I have files, just go and run stuff, and then tell me how many files out of the 10,000 I've downloaded, or tell me how much data I've downloaded so far, because you might be worried about the egress charge on your environment. And to kick that off, as I said, we use our starting point, which is our HTTP start. And the say hello doesn't really do anything. It just says hello and passes a name. So if I go back into my HTTP start here, you'll see that we are passing some names to our function. Sorry, that's not the right one. It's here. So I'm saying call my say hello function with these parameters. So that will be the different places there. And that can be anything. Again, remember, you actually define what you want to consume. So any questions or no? Okay, cool. So if I were to run this one now, I have a nice endpoint here. Just to show you where that's coming from, just in case. So if I go to my HTTP start, that exposes an endpoint. And that endpoint says, you can call me with this URL parameter, this URL. And in the end, I expect the function name of my orchestrator to be passed in. So without any further ado, let's run this thing. Now it takes some time to start up. And that's because when you run your function on the consumption model, we tear down your resources so you don't pay for cycles. And what happens is the next time that you kick them off, it might take a little bit of time. Now that time may be between 1 second all the way to 30 seconds, depending on how many dependencies and libraries we need to load into the runtime to allow you to run. Now you notice that's a bit different, right? We didn't get the status back, we didn't get the result of the functions. We got 3 URLs that we can use to investigate and look into the results. So here, yep, there you go. So here, you'll see that we have completed. So we can interrogate the status. It says the output was what we outputted from the durable function, and this is how long it took to run. There you go, easy as that. So now if you want to manage state, we give you the option to do it with durable functions. Now they're also supported in Visual Studio, and they're also supported in .NET, but we're expecting to extend that to other languages as you saw in the roadmap. Everyone with me so far? So that's one of the advanced scenarios. That's something that the customers have been asking for, and we made it available. So the next one I want to cover, which is also very fun. Let me see. Yeah, we have another demo, which is our monitoring. So I did say that we have really good integration with monitoring stuff. And in the early days, if you wanted to look what your function did, you will come down here. So that's probably not the best example, but if we come down to here and run it, you can see the logs down here. It's thinking about it. Yeah, there you go. So down here, what? 500 there? Why? There you go. So you get the logs down here. I don't know what happened there. And that was the only place that you could get your logs. It wasn't really intuitive. It wasn't really helpful. So what we did is we said, how about we integrate with App Insights? So you see that spike over there? That's me actually hitting that request endpoint. But I didn't log an error, which means that the whole process was not running. Now, if I wanted to put that into a test, I have a nice, how many of you use Apache Bench for load testing? No? Clear. So let me just find the command somewhere around here. There you go. So what I'm doing here is, what I'm saying is, run Apache Bench, create 1,000 requests, send 100 requests at a time, and then hit that endpoint and tell me what the metrics are. And the reason I do that is so I can actually see my thing spike here. So are you ready? Let's go for it. So if we come back here, we should see something eventually. There you go, it's down here. So that's the first hit that comes in, spikes a little bit because we are processing them, and then it tears down. There's no errors, obviously. Okay. So I can run it again just to prove the point. And we run it, absolutely fine. It tells you how many requests took how long and so on. What was the longest request? Again, do that. And there you go. Now you see a little bit better performance here because we anticipate that you might have some load, so we warmed up some instances for you. Seeing that? Oh, that's better. And, the more you run it, the more sustainable the load will be. So we have really good integration. Now you might say, well, you're only showing me the live metrics. So this is live stuff. As things happen, we actually give you live metrics, which is probably one of the best things there. And if you have any exceptions, we capture them on the right-hand side, and you can say, right, I want to filter on specific traces, and so on and so on. Now, some other awesome stuff that we have for these things is obviously some metrics on your HTTP requests. But we have a dependency map. How many of you have used the dependency map? So if I go more, what is that? There you go. So that's our application map. Now, if my function was calling other functions or going to an external API like SendGrid, or was going to process anything in the back end, we could actually capture all that information and then see how our dependencies are working. So maybe your functions are functioning absolutely fine, but maybe another API that calls back to your database is not working really well. So you can see here how many requests you do, how many failures, how long they take per average, which is 62 milliseconds. Brilliant. And that would span out into, as you have. App Insights also provide brilliant support for web apps. And because functions run on top of web apps, we give you that full integrated support. You can also enrich your data by instantiating a telemetry client and then having custom logging inside the function. So by default, we'll capture any trace, as you saw earlier on. So some of the functions had some trace logging here. If I go into my .NET one. But if you don't have any tracing and you want to do some custom logging, you can extend it with the telemetry client. And to set it up, all you have to do is just go into your function with the settings. Not here, I want to go into here, one level up, and app settings, you can go here, and you just need to provide your instrumentation key, and that's all you need. Brilliant stuff. And then once you have that, it runs absolutely fine. You don't have to worry about anything else. Okay, so we covered that one. Let's see what we else have in the slides. Yes, question, go. How do functions scale, and how do they compare with Azure Batch? First one, magic. I'm just kidding. We actually have a lot of infrastructure behind the scenes, and the way that we do, and the way we monitor your loads, and for every request that comes in, if it takes more than a specific amount of time, we'll just scale out, right? So it will scan instantly. The team has actually released a blog post about processing 100,000 requests sustained per second for 2 weeks. So that was 100,000 requests sustained for 2 weeks not in a row, and how long it took and how it processed, and you can see and read all that. So we scale for everything. I mean, we scale for IoT. You send us 1 million requests, we'll process them. Now you need to be aware of batch is a lot more complex, because batching can be any executable they can deploy into a node, but that's a full node, right? You have a full node there to manage with, not a VM in between, something like Service Fabric. And then you say, this is where my data sits. Go into the storage account, manage all the queuing yourself, but then again, you say, I want to run on 10,000 nodes. So you have this kind of a predictable workload, and it's not triggered. Whereas functions are always triggered by something, whether that's a timer or an event. And it's usually an event Does that answer your question? Brilliant. But we do scale almost infinitely as long as your pocket can afford it. So we've done the App Insights demo, compute options, and how do they cost? How much does it cost? I did mention the example earlier on with the bank, where when we announced how much it was going to cost, it just blown apart because it was ridiculous. And we have customers that don't really pay lots of money because, again, nobody is going to reach the 1 million executions for free, or they're not going to be running for a long time. We do have a hard limit, though, on the time that you're going to be running stuff. So by default, we'll stop your functions in 5 minutes. So if your function is running for 5 minutes, we will kill it. That's to protect you and to protect us. Did anybody read a blog post by a guy that was playing with AWS and he got an alert about going over his limit, and it was like 800 pounds because he forgot, and his function was actually calling the same function over and over again. He actually created an infinite loop, and nobody stopped it. So to protect you against these things, like you make a mistake, we will do that. You can tweak the settings to extend them to 10 minutes, but then again, you need to start thinking, if my function is taking more than 10 minutes, maybe it's not a function anymore, it's an app, or you need to run on a web job, or something that is more appropriate, or a batch service, because you're doing more, or Azure automation. It's not a hammer. My team calls my approach to functions as a hammer because I find lots of different solutions with that, but there's always the right service for the right job. So we have two options. One is the consumption plan, where you pay per execution. You don't have to worry about how many servers, how many instances you're going to spin up. You pay per invocation, and that's for high productivity, less control, but it's for unpredictable workloads. IoT, for example, where you might have 1,000 events now, then 10,000 events, then 5 events. It's very unpredictable. And that allows you to respond to events more quickly, but it's a fire and forget for scaling. On the other hand, if you have predictable workloads, like you know you're going to be processing 10,000 files at 5 p.m. and then at 6 p.m. and then stop and then not do anything for another 12 hours, then it pays more to actually deploy on an app service plan, which is the same as a web app. And there you actually have your dedicated resources, but you have to manage the scaling. You have larger memory and larger CPU. You can run for longer. You can have the sustained always on. Has anybody seen that option inside web apps where you say, I want my function to always be on, and we'll just ping your application to make sure that it's up. So there's no warm-up time when you hit your functions. So if you are concerned about the warm-up time, then the service plan is a good solution for you. There's more network isolation, obviously. More cost-effective because you pay upfront for the resources, but you have to manage the scaling. So if your applications are starting to run and you have lots of function invocations, then you need to start thinking about scaling. You can automate that as well, but it's not as easy. So you can learn more. You can actually go and try functions without even having an Azure subscription. You don't need an Azure subscription to try it. It's obviously a subset of the functions, but if you want to do some funky things and try some stuff out, then we do give you a free account. You can follow the team on Twitter, Azure Functions. The team is very active, and they are also on GitHub. So for any issues, and I'm kidding you not, I was doing a demo 2 weeks ago with the core tools, and they were broken. That was like 2 days or a day after they were released. I'm like, wait, I'm going to demo the new stuff. And then 1 a.m. in the morning, it still doesn't work. Put it on GitHub. Within 2 hours, they had a new package released, and we're able to demo the stuff the next day. So they are very active and very quick, and they have a very nice channel about Azure Functions. What I have one more demo to show you guys. That's not scalable APIs, but it is scalable APIs, in fact. So one of the things that customer asked me, I know we only have 1 minute, but I want to use that to actually show you how easy it is to get off. And it doesn't have to be your APIs as well, right? So in here, I have a very nice example called my APIs, where I use proxies. And with proxies, I can go and create Here I can create proxies, where it means I can actually proxy into a function that can live inside AWS. It can live on premises. It can be a function app. It can be your API. It can be a node app that sits somewhere else. And in fact, here I have two things. I have my weather. So let's go and grab that and run it. So if I go here very quickly, we can do that. Right, I don't want to leave you without the demo. So we put Amsterdam there. We're in Amsterdam, right? So why not? Amsterdam. So this API is just a third-party API. It's not even my account. It might take a little bit of time to warm up. But the idea is I'm calling to a third-party API. I haven't exposed my key anywhere, so you don't see my API key. Come on, you can do it. There you go. LAN, weather, the whole thing. I have a movie one. Who wants to give me a movie quickly? Movie, any movie. What do you want? What? Redemption? No, an easy one. Let's do Deadpool. So that's an API that lives somewhere else. Totally different API provider. It doesn't even have spaces, so that's going to work very nicely. There you go. And then I have another one that says a hello name, and then I can pass that, and that's a function that lives inside my thing. So you can use proxies to actually proxy everything, and you can have lots of different functions that live on total different places. You can create microservices, or picoservices I like to call them, by using proxies to front them through a unified API endpoint and expose them to your customers or your users without them even knowing where these APIs live. So that's a very clever way to do that. And it only takes 5 minutes to get started with that. And that's me, with 30 seconds on the clock. Thank you very much for coming. Please grab me outside if you have any questions. And I don't have my stickers with me, but if you see me around the hall, I'll be carrying my stickers. If you want anything to let me know. So thanks very much for coming.